Last class we have discussed till question number 11, right? So you have asked me to explain the 12th question as well. This I'll take the example from the PPTs that I have discussed before. Okay, here the question is illustrate BNF and EBNF grammar assignment statement with the help of parse tree. Okay, alternate parts are represented with vertical bar enclosed in parentheses. And if you have 0 or more to represent, we can use open and close braces. So let's see here, then this term is being further defined to be term into factor or term by factor or factor. Now, how are you going to represent this, right? How are you going to represent this using EBNF? Fine, this whole thing, okay, we have represented it with a single statement, you can see, right? What we have said, expression defines to be, you have only term also, right? So you have just used term, and then braces basically used to represent what? 0 or more. It means when you use 0, there is nothing here, then it represents this, just term, because you have term here, right? So it is going to just represent term. But let us say you have used it for one time. If you have used it for one time, what do you get here? Term plus or minus term. So here in parenthesis, what we have can be used, alternatively. So it means term plus term. So this term plus term is going to be represented here. Okay, this one, and then term minus term. So this one also being represented. Plus and minus, both are going to be represented. What the point? Now, it means expression has been defined with all possible definitions here with the help of a single statement. Yes, you can see here this has been defined with a single statement where it is covering all three definitions. If you take this 0 time, it will give you this definition. If you take one time, then it will give you the definition of these two statements: term plus term and term minus term. Okay, so then you can take the next statement. Here you have defined term. So while you are defining term, again you have term defined to be term into factor, term by factor, or factor. So here we have again defined this by clubbing this three statement into a single statement. You can see factor, term defines to be factor, and then this whole represented in braces. So the denotations represented in braces being used for 0 or more time. So if I use it for 0 time, then what happens? Term is defined with factor, the last definition. Okay, the last definition. But if let us say term here, if I take this for one time, okay, if I take this for one time, then I will get how many definitions here? You have the denotations inside the parenthesis can be used alternatively. So I can write like this: factor into factor, and then by the next time. See, this R symbol comes, and then I can use it for another time. Fact by. If I use this for 0 time, if I use this for, I will have this definition. You can see I got how many definitions? 3 definitions. Term, and this is 0 time. And when this is 1 time, I got both definitions. Okay, when this available for 1 time. Because when I have it for 1 time, I can use both these operators alternatively. So you can see factor is already there. factor into factor, right? Or factor by factor. So all these definitions are written. So it means here with the help of EBNF, what you can do is you can compress the state. Okay. I hope this is clear. Okay. The first statement is going to be common anyway. Right. This is BNF. And in EBNF, first statement is anyway common. Now, I am combining all this into a single statement. This A assignment statement or an expression defines to be. Here I have how many operations plus minus into here. And then I have term also, right? I need just term also. I just say term. And then within, the braces, I'm saying plus minus into divide. Then say term. Then I have closed this. So I have written all these 4 or 5 statements, right? How many statements I have? 1, 2, 3, 4, 5. 5 statements I have combined with a single statement. A defines to be term. Within braces, I said plus or minus or into or divide. Okay. Then I said term. Now, when I use this for 0 time, it represents just term. It satisfies this definition. When I use it for 1 time, what happens? It will give me how many definitions? Term plus term definition, first one, and term minus term definition, second definition. I have into also. So term into term. When I use into, I'll get another definition. When I use divide, I'll get another definition. So it means you can see if I use this 1 time, this is for 0 time. If I use it for 1 time, then all these definitions are being covered. So instead of writing these 5 statements, I can write it with a single statement. Okay. So this is the advantage of using EBNF. And for this, I can't combine anyway. This term ID is going to be the same, but for ID A, B, or C, okay, A or B or C is there. You can have the same statement because you don't have any repetitions or the chance of being combined. So the remaining things will be the same, in EBNF as well, right? So here you can see, okay, this particular statement where you have 5 statements together are being combined into a single statement, right? This is the advantage of using the EBNF grammar. I hope this is clear to all of you. Constructing the parse tree is going to be same for BNF or EBNF, right? When you construct, you will get the same kind of tree, whether you construct it using BNF or EBNF. The advantage of EBNF is only while representing the notations, you can compress. While writing the statements, you can compress the BNF statement into less number of statements when you write using the EBNF. That is only an advantage. But otherwise, parse trees are going to be same. You don't find any change. Okay. I hope it is clear to all of you. Right? Later on, I can say attribute grammars help you to implement the static semantics. Okay, like one example which I mentioned, type compatibility. Okay, for example, you are adding two numbers here. For example, you have written assignment statement in which you said two variables can be added, variable plus variable you said. But then if you do not mention the type and the user is taking different kind of type, are you going to allow different kind of type of data to be added or not? You are going to specify it with the help of this attribute grammar. Means you are going to specify the data type of the variable. In BNF or in context-free grammar, context-free grammar we are implementing it. One thing you make it clear that we are implementing context-free grammar with the help of BNF. First thing, this is clear. Next thing is there are certain things which I cannot define in BNF grammar, okay, in context-free grammar, that I can define it using the attribute grammar. That is helping you out. Attribute grammar will help you out to specify certain things which is not possible with the context-free grammar. Like for example, type, data type. Okay, if I have to specify the type of the data when I am specifying the operation, okay, so that you can prevent the user from using the different type of data being added rather. The type compatibility is one issue generally when you have different type of data adding. Okay, when you're adding different type of data. For example, I'm adding 2 plus, let us say, some 5.6. This is integer, this is float. Okay, so I have written, let us say, the grammar more generic way, because in BNF you write in a more generic way. So then this 2 plus 5.6, you know that this is different. Integer doesn't have the fractional part, so 2 and 5.6 when you have, if let us say there is no specification given to the grammar, then what it may take, it may either go with there should be some kind of type conversion mechanism required to be implemented by the program designer. Okay, the language designer must have to specify the type conversion mechanism. If you have different type of data to be added, there are two types of specifying the type conversion mechanisms available in most of the languages are implicit type conversion, implicit and explicit. Okay, implicit means that programming language itself will take care of the converting it into the required type. This kind of conversion is said to be the type coercion. Type coercion. Generally, C language will exhibit this. C++ will exhibit this. I mean, it is having implicit type conversion mechanism available. Whereas other in C++, if you leave, then like for example in Java you have explicit, and in explicit the user must have to take care of it rather, right? User have to take care of it. He has to convert the data type. So for example, I said 2 plus 5.6. I can't say 2 plus 5.6 in Java. So what I do is I will convert it. I say like this: 2 plus int of 5.6. It means this 5.6 value will be converted into integer. When it is converted into integer, you will get 5 here, then 2 plus 5. So we'll give you 7. Okay. In Java, the programming language wherein you have explicit type conversion mechanism, you need to specify, you need to do the type conversion, on your own, specifying like this. This is said to be typecasting also. You call sometimes as typecasting or type conversion. Fine. So this is done explicitly by specifying that this float I want it to be converted into int first, and then the integer value that I get out of it should be added with this in order to get the result. But in C or C++, if you take where you can directly, if you add like this 2 plus 1.6, the language designer will take care of it, right? Of course, he will also do the same thing, that he will convert the language compiler is going to convert this float value into integer. Integer value is 5, right? Then this 2 plus 5 will produce you 7. So here you are not specifying this typecasting, explicitly in C, C++. Okay, automatically the language designer is the compiler, the language compiler is taking care of it, because the language designer has taken care of it, rather, right? So that kind of conversion is said to be implicit type conversion. So these kind of things you can specify it using the attribute grammar. So attribute grammar, where exactly attribute grammar is coming in picture is these kind of things. If you have these are said to be the issues the other way around, I can say. So these issues are not being addressed by the context-free grammar or BNF. Right? BNF is just an implementation of context-free grammar. Okay. So these kind of issues are not being addressed by the BNF. So to address these kind of issues, attribute grammar will help you out. So in attribute grammar, you are going to use static semantics. Okay. Why you are saying static? Because the semantics are being checked at the compile time itself, right? And then specify the type of the variables and make the type of these variables clear before the execution. Okay, even if you give a different type of values as well, but what kind of type that particular value should go with will be decided at the compile time. Okay, so this is going to be done by the attribute grammar. So the language designer here is going to specify these kind of issues being addressed with the help of this attribute grammar. Okay, so if you take this particular example, I'll explain you the same with the help of this example. See, in this example, the same assignment statement has been taken. Variable equal to expression is said, expression is variable plus variable, and our variable is said, variable is A, R, B, R, C. Now the question is, this variable could be of any type, right? It could be integer type, or it could be float type, or it could be string type, or it could be subrecord type. But then if the user is giving different type, okay, on LHS and RHS, in general what happens, the LHS part and RHS part of the operation must be of the same type. But if he is giving different type, what happens? Are you going to produce the result? Are you going to add it? If I give, let us say, character value here, if I give some character value here and I give integer value here, so I want integer plus character to be done. How this is going to be done? Will it be taken care? No, right? But the language designer or the language compiler is having some kind of implicit, type conversion, like type conversion mechanism. Then of course it is possible, right? And but how that is going to be specified to the compiler? With the help of attribute grammar. Okay, like for example, in C only, in C language you take, when you add, let us say for example, 2 plus some character value. How do you represent the character value in C language? In single quote, right? In single quote. So if I add, let us say, 2 plus A and some variable I have taken small a, in which I want to store this result. In C language, this is allowed. Okay, you can add different type of values. Okay, but then the language compiler is having, since the type conversion mechanism, it is converting this character value into integer. The ASCII equivalent of this character in decimal is 65, right? So 2 plus 65 will be 67, and that will be placed in A. So A value becomes 67. Right? This value you are getting it. How you are getting it? Since the language is having some specification to take care of it. When you have different type of values to be added, okay, this value must be converted into first integer kind. Since you have the left operand is an integer, so you are converting this into integer and then you are adding it and then you are getting the result. That's good. But then if the language does not have the specification, what happens? Fine. If the language does not have the specification, then it will strictly mention that, you know, the type of the variables of both left and right must be same. Okay, that also you can give it with the help of attribute grammar. So the same example here is given with the help of this attribute grammar. Here you can see where he is specifying that the type of the variable 1 and the type of the variable 2 must be same. Okay, the actual type of these two variables must be same. Only then the expected type of expression can be met. Okay, this is what exactly here you can see specified in this grammar with the help of the attribute grammar. You can see expression, okay, defines to be variable plus variable, you said. Okay, variable defines to be A or B or C. Actual type synthesized for where and expression. Expected type inherited for expression. Now these are the specifications you have given for actual type and expected type. And now we are implementing in the next page. You can see here, this, what do you mean by predicate? Predicate is nothing but the condition. So here you are specifying a condition. Okay, you are specifying a condition that variable 1 dot actual type and variable dot 2 actual type. These both must be same, you are saying, right? If these conditions, if this condition is satisfied, it means the actual type of variable 1 and the actual type of variable 2, if both are same, only then the expression's expected type will be, you know, rather achieved. Okay, rather achieved. So the actual type of expression, of course, you will get with the operation that you perform on these two variables. Okay, and then the resultant expected type will be satisfied. Okay, so you are giving it with the help of some rules here. You are specifying the rules. You are saying that the variable 1's actual type and variable 2's actual type must be same. Only then the expression's actual type will be met with the expected type. Okay, this is the condition you are specifying. This is the rule you are specifying. So this kind of thing you can't do it with the help of normal CFG. Normal CFG, context-free grammar. You are implementing the context-free grammar with the help of what? BNF or EBNF, right? Got the point clear? And additions of the CFG, additions over the CFG like this, okay? Specifying the data type and specifying the type compatibility rule. Okay, all this you can do it with the help of what? The attribute grammar. Okay, attribute grammar. So attribute grammar is the other way around, is checking some semantics you are saying, right? It is checking the type, in this case it is checking what? Type compatibility, the other way around I can say, right? It is checking the type compatibility. When you are adding two variables, okay, of course their values are going to be added, which you have read before rather, but their type must be same. Only then you can probably allow the operation to be carried out. Okay? Addition can be done on two integers, okay, or two float variables, or two character variables, but you can't perform addition on one value is integer, the other one is, let us say, some record or character or float. You can't perform. When you have the different type of values, right, you can't perform the operation. Got it? So to restrict the user, to prevent the user from using the different type of values while being added, okay, you are doing it, or you are restricting it with the help of the attribute grammar. So the other way around, I can say attribute grammar is preventing the user from having the different type of values to be added while carrying out the expression. Got the point? Yes. Full defines to be ID, right? So from where the ID value comes from, Okay. The actual type of the variable comes from lookup of variable string. Variable string you have specified as A or B or C before, right? This is the variable string. What the point? So lookup in the sense you are going to identify or pick one out of it, right? You are going to pick one from the string of variables which are given as A, B, C. So the actual type of variable here, you are defining that it has to pick a value from the string of ABC or C. Okay?
Okay, sir. Thank you, sir.
Okay, I think it's only 10 minutes left, but shall we move on to the, otherwise we will start our pointers class probably in the next class. If you have still any doubts in the first unit, you can rather ask me so that I'll clarify. You have to, in the sense, basically, when you have some features defined by the programming language where the features are perpendicular to each other, okay? Orthogonal means perpendicular rather, right? Perpendicular to each other, opposite to each other. One example I can say is arrays and structures. Got the point? Why I say from property point of view they are perpendicular to each other. If you look at the characteristic of arrays, what is the definition of array? Set of homogeneous elements, you say, right? Set of homogeneous elements. Whereas structure language is providing or offering, then we say that language is, offering orthogonality feature. Orthogonality is a concept or a feature, I can say rather, right? Or a characteristic. Okay.